Our project can basically be split into three parts: generation, parallel, and the visualization part. So in the first part, generation is here. I'm trying to draw a graph on the planner. So as you can see, all I have here is straight lines and everything is on a plane. So it is proved that all the planar graph is full colorable. So we use this as a fundamental check for our algorithm. So we can check if the output of the planar graph is full colorable or not. So apparently these graphs are not complicated enough for us to run on the run the code. So what we do is that we have a more complicated generation Python script which generate a graph using. So the graph we generate out is bidirectional and uses specified number of nodes and number of edges. So this will be a more complicated graph using the output fashion where the first line is the number of the vertices and the following line specify the starting point, starting vertex, and the ending node vertex. This is a very simple example here. And then as you can see, this is in the same fashion as we generate from our planar graph generator. So we have two generators for our script. So the main part of our code, so this is the second part, the parallel part, is that basically we use a largest degree first, as Yushen has already covered. So where we read the graph, and then we initialize both the OpenMP and MPI threads, and we start working on the LDF part and output the correct output. And then there is another two parts for the graph. The first one is parallel and the other one is sequential. So we compare the running time for both the parallel and sequential parts. As you can see, this is our sequential output and sequential code. So the last part we're going to cover will be visualization. So it won't be as simple as we had in the browser on the web, because it's not a planar graph, so it will be very complicated to show on a computer screen or basically anywhere. Oh, so before that, let's check the script where we do the output. Yeah, so here when we read the output of our color method, and you can see this color, this has been colored into 8 colors. So all these colors, where if you hover the mouse onto each vertex, you can see it's all its neighbors. So here we can try to squeeze them out and see where their neighbors are and see if they're of the same color. You can move the vertices like I did. So after, let's close that. And so now when we check the code, our visualization script, this is a simple script that I adapt from online. So it can read. I changed the I/O so it can read what we have here, and the display and the node script I changed a little bit so it can pick a random color for each cluster we group them into.